So before you can understand today's lesson, you have to know the zero property of multiplication. Anything times 0 is equal to 0. 10 times 0 is equal to 0. Pi times 0 is equal to 0. Negative 2/3 times 0 is equal to 0. A purple elephant times 0 is equal to 0. It doesn't matter what it is. If you multiply it by 0, it's equal to 0. And if I'm going to have an answer of 0, I have to have a factor of 0. The only way to get 0 as an answer is if 0 was a factor. Would you agree that that also comes from this rule? And so you have to know that rule to be able to solve by factoring. All of that solving that we have been doing has been in order to help us solve by factoring. So I need you to write down these steps, and then I'll show you how to use these. So after you have copied down the steps, then I will show you an example. So our first example is 3x squared minus 17x equals 6. We're going to use what we've learned about factoring to help us solve this. And we are solving for x. Do you see right here that x is squared? When x is squared, we're solving for x, and we will have 2 answers. If we had a cubic, if we had x to the 3rd power, when we solved it, we would have 3 answers. If we had an x to the 4th power, we would have 4 answers. If we had x to the 5th power, how many answers would we have? 5. Aren't you glad we aren't going to do that kind this year? So we are looking for 2 answers, and we are going to solve this by factoring. First of all, it must be in standard form. The ax squared plus bx plus c all have to be on the same side of the equal sign. So I need to move this 6 to the other side of the equal sign so that it will be in standard form. It needs to be in standard form, and it needs to be equal to 0 in order to solve it. We in standard form, or we equal to 0? Then we do like we did before. This is a trinomial. The first thing we look for is a GCF. Does it have a GCF? So what is the A? What is the B? And what is the C? Like we did before. And then you multiply the A times the C and write down the factors of 18. And 2 and 9 and 3 and 6. If this is negative, the bigger number has to be negative. If this is negative, they have to be opposites. Are there any pairs that could add up to equal the negative 17? And since the A is not 1, we have to factor by grouping. And so the 17 becomes those 2 terms. Is this familiar? So that we can factor by grouping. So an x factors out of this term. A 6 factors out of this term, and if this is negative, I need to factor out a negative. So I factor out an x. X divided by x makes a 1. Factor out a 18 divided by 6. 6 divided by 6, the negatives cancel out. By the way, don't leave out your equals 0. You don't leave it out on all the steps and then throw it in on the bottom. That is not mathematically correct. I know your greatest desire is to be mathematically correct. As I have said plenty of times, if you have done this correctly with the correct GCF, then you will have a common factor. So this is where we stopped before. It is factored. Now we're going to add another step to it. We're going to actually solve it and determine what x is equal to. What x do I have to have so that this equation up here would be equal to 0? Well, these are multiplied together and they're equal to 0. Our 0 property says if you're getting a 0 for the answer, then one of both of these factors have to be 0. That's the only way you can get a 0 answer. That's what we started with. So either the first term has to equal 0 or the second term has to equal 0 or both. So once you get it to this point, you break it down into two small linear equations. These are called linear equations because the x isn't squared anymore. Can you solve this for x? Can you subtract 1 from both sides? Can you divide by 3? Can you solve this little equation? Add 6 to both sides. Do we know two values for x? The solutions to the equation, this is with a set bracket, the solutions are -1/3 and 6. X is equal to -1/3 and x is equal to -6. If you plugged either one of those numbers back into this equation, it would be equal to 0. If you went all the way here and plugged it back into this equation, it would be equal to 6. These are the solutions. These are also called the zeros, because how did we get them? By putting them equal to what number? 0. So the solutions are also called zeros. Example number 2. 2x squared plus 4x equals 0. It is in standard form because everything is on the left-hand side of the equation all together. X is squared, so I'm looking for two answers. So what's the A and the B? But what's the C? The C is 0, that's why you don't see it there. And so, but we don't start immediately multiplying the A by the C anyway. What do we look for first, trying to factor anything else? Do we have a GCF here? What is the GCF? And this GCF is factored out in front, it's not thrown away. And so the 2's cancel and the x's reduce. The x's cancel and the numbers reduce. It is factored. The reason we are factoring is to get rid of x squared. Have we gotten rid of x squared? And so either the first factor is equal to 0 or the second factor is equal to 0. Do we have two answers? These answers are called solutions. I actually should have written them the other way around, because if possible, you should write them in order from smallest to largest. And so these are the solutions. Another name for the solutions is zeros, because that's how we get the solutions, is because it is equal to what number? 0. 2x to the third power plus 20x squared plus 48x equals 0. X is to what power? The third power, so we are looking for 3 answers. But before we do anything else, the first thing we look for is a GCF. Do we have a GCF? 2x again. So the 2x comes out in front. Let's do this correctly. This number should be a 24. Now, looking at the part in the parentheses, the A for the part in parentheses is 1, the B is 10, and the C is 24. When you multiply the A times the C, that's a positive 24. Everything in this problem is positive, so all of my factors are going to be positive. 2 times 12, and 3 times 8, and 4 times 6. And everything's positive because this is positive and this is positive. So, which pair of factors can add up to equal 10 if everything's positive? Because A is equal to 1, I can use shortcut factoring. I can replace this with a 4 and a 6, x, do factor by grouping. But if A is equal to 1, I can do shortcut factoring. Those are going to be the factors. This pair right here. That's what we learned before we did factor by grouping. And either the first term equals 0, or the second term equals 0, or the third term equals 0. So I have 3 little equations to solve. Divide this by 2, subtract 4, subtract 6, and so this time I have 3 solutions. You should put them in order from smallest to largest. And why did we have 3 solutions? Because x was to the third power. So we're taking our factoring and adding 1 or 2 more steps to it. We're adding solving. Now, you cannot solve an equation unless it's got an equal sign. What we were factoring previously were expressions, and they didn't have an equal sign, and we couldn't solve them. But now that we have an equation, we can solve it. If we're going to solve by factoring, it has to be equal to 0. And you do GCF first. What's the GCF? So this is going to be x squared minus 9 equals 0. Oh, thank you. Should be 4x squared. After you factor out the GCF of 2, you have a binomial. The only way you can factor a binomial after the GCF is factored out is to have the difference of two squares. Do we have the difference of two squares? Is 4x squared perfect? Yes. Is 9 perfect? Have you memorized the pattern yet? So either the first term equals 0, or the second term equals 0, or the third term equals 0. Can 2 equal 0? You don't get any solution from that part. Notice I did not say that the answer is no solution, because we still have two solutions. By the way, if it's x to the second power, how many solutions are we looking for? 2. And so then we are going to subtract the 3 from both sides and divide by 2. And we're going to add 3 to both sides and divide by 2. And we have 2 solutions. Another name for solutions is zeros. (15x plus 50 equals 2x squared). Before you can factor, it needs to be in standard form. ax squared plus bx plus c. They need to all be on the same side of the equal sign. Now, I would not move the 2x to that side because I do not want to try to factor something that starts with a negative. It's possible, but I usually mess up the signs. So I'm going to subtract 15x from both sides, subtract 50 from both sides, 2x squared minus 15x minus 50. For a GCF. Is 2 a GCF? No, not because of the 15. We do not have a GCF of 2. And so the only thing that divides 15 is 5 and 3, and those don't divide 2. So then we multiply the A times the C. So we have 1 times 100, 2 times 50, 4 times 25, 5 times 20, and 10 times 10. If this is negative, the bigger one needs to be negative. If this is negative, they need to be opposites. Any of those pairs add up to give me a negative 15. Since this is a 2 and not a 1, I can't use shortcut factoring. I have to use factor by grouping. Plus 5x minus 20x minus 50. I replace this with the 5 and the 20 so that I can make 2 groups of 2. What factors out of this first group? If this is a minus, I need to factor out a minus. Minus 10 look like the biggest GCF? Factor out a minus 10. Minus divided by a minus makes that a plus. If you have not made a sign mistake, you should have a matching factor. You have 2 factors so that you can get the 2 answers. Minus 5, 2x equals negative 5. So my solution set is negative 5/2 and 10. I'm waiting a second because I see that people are still writing. Example 6, 49x squared equals 28x minus 4. In order to solve this, I need to subtract the 28x from both sides, add 4 to both sides, and get 49x squared minus 28x plus 4 equals 0. This does not look fun to factor. Is there a GCF? No. And so I need the factors of 49 times 4. That would be a positive. Okay, if this one is positive and that one is negative, these are going to have to be negative times negative to make a positive. And so, 2 and 98. 3's not going to go into it, but 4 will. Negative 4 and negative 49. 5 won't go into it. 6 won't go into it. Will 7 go into it? And we are, did I do that right? What? Yes, there is. We have to find it. That one was a little bit more difficult to find, but we did find it. What is the GCF here? Do you know that 7 goes into both of those numbers? What is the GCF here? And if just 2, 4 doesn't go into 14. And so we factor out a 7x. We factor out a 2. So 7x minus 2 equals 0. 7x minus 2 equals 0. Add 2 to both sides. Divide by 7. And what do we notice about the answer? It's the same. And so there is one answer, it's an answer. We got the same answer from both of our factors, and that's why it looks like there's only one answer, but R2, that answer is a double answer. So, do you understand that if you didn't learn your factoring, that this part's going to be really, really hard? And so that's why we spent quite a long time working on factoring. So now you're going to use your factoring to solve quadratic equations. I don't think I explained the word quadratic, did I? These, all of these except for problem number 3, all of the rest of these are quadratic equations. If it is raised to the second power, it is called a quadratic equation. And I keep losing my mouse.